in drawing will take more time. And then mass of cylinders. Where is the mass of cylinder? There is the mass of cylinder. M, this M. Moment of inertia, everything is given. Okay, let's, and radius also given 1 meter. Cylinders are mounted on their central rotation axis of this one. The rear cylinder is connected to battery operated with a, which provides a torque of 100 Newton. The rear cylinder, what is the rear cylinder? The back. There's a front, there's a called as rear, no? All of you, front, there's a rear. It is connected to battery via belt. Where is the belt? There's a belt. I'll show the green color. There's a belt. Don't get scared. Problem you see very simple. Just to have a generalized idea, we are picking up numericals of this one. This is a belt. This you call belt. Fine. That will provide a torque for the rear cylinder. If sufficient, if sufficient friction is present between cylinder and horizontal surface. I think almost the problem is over. For pure rolling, find the acceleration of the vehicle in multiples of 5 meter per second square. Neglect mass of motor, belt, and other accessories of vehicle. So what is the mass of vehicle? M. Mass of cylinder is M. So what is the total mass of system? 3M. What best you can. So where is the torque acting? Straight away jump into the problem. The torque is acting on the rear cylinder. That is what this torque. And now when torque acts, what happens to point of contact? Will move backward. So how the friction should act? The friction on the front cylinder, on the rear cylinder should act forward. Sir, how do you can see? Because first when you switch on, so which cylinder? This cylinder will not at all rotate. First this cylinder will rotate. When it rotates, point of contact will move backward. Then the friction will act forward. This friction acting, what it does, will push the vehicle forward. There's a thing, will push the vehicle forward. As it pushes the forward, so this particular cylinder weapon will be pushed in this direction. Then the friction will be like this. I'll have water. Okay, now how to get the direction of friction is the idea of the problem, nothing big. The torque acting here will make this first, when you switch on the motor, the belt will set up a torque, and because of the rear cylinder will rotate, so point of contact here will move backward, friction will act forward. This friction is what the net action force acting. That action force will push the vehicle forward. So then the cylinder also will move forward here. Then only translative motion initially. The point of contact here will slip forward, so friction will act backward. This friction acting here now will set up a torque on it. Oh. Will set up a torque. Alpha is not angle. Alpha is not angle. I had to wait to show this alpha. Yeah. So why is both the cylinders will have same thing? Because I think in a vehicle, both the rear and front wheel will have same angular velocity. Check it once. Now the total acceleration of this, let it be A. Then what is the basic equation we can write? First, F1 minus F2 is equal to 3ma. Then the torque acting on rear cylinder, tau minus F1 into radius, let me take small r. Should be equal to how much? I naught alpha. Moment of inertia also given, I naught. Then from the front cylinder, F2 into R equal to I naught alpha. Then for pure rolling, A equal to R alpha. So on the cylinder, I'll show individual cylinders, what are the forces acting. torque, friction, then acceleration, this alpha. So instead of, and for A quote R alpha on individual, and for the next cylinder, F2, then some student they're asking, sir, they should move backward. If it happens in vehicle, that front will, rear will move forward and the front will move backward. Altogether, the system will move forward, no? So therefore, you just discuss the total system, net force acting on system, F1 minus F2. Sir, will there be any tension, this component of tensions? If you have said, you would have considered. You didn't say, no? Neglect mass of motor, belt, and other axis of vehicle. So what all the tension setup? That will not. In fact, this tension here will be component of tension also should come, but the tension will be very small, will not be sufficient to make the vehicle to move. So neglect the, so you can, if you want, you can add it. Neglect tension force in belts. I think we can solve it. So this diagram I should not show it because again the sorry because F2 is acting. So here what makes the, say as the vehicle moves, what happen? This particular cylinder will be connected to vehicle, no, to axle. That axle will push it. Fine. So this I think will give wrong idea for a student. So therefore I'll take it out. So you should discuss the total system. You'll be in better position. Similarly here also, sir, F1 equal to, okay, this also I take it out. Always discuss the total system, you'll be in safer side. Solving this will get the required answer. Similarly, sir, if a torque acts on the front cylinder, so definitely what happen, sir, like you can go for a generalized like this. So definitely they may ask you conceptual question. If this is a vehicle, so the vehicle will be either the engines, what happen, front wheel driven engines and back wheel driven engines will be there. Now, if a torque is acting, torque by the engine is like this, tau E, I'll write it. So here what happens, the engine is placed at the front. You look at the Volvo buses, where the engine will be there on the rear wheel, no? Okay, the front wheel engines here, the torque will be set up here. So you can just show this is the engine. Let's assume that one. So now in what direction friction will act here? The point of contact will slip backward. So friction here will be in this direction. Take F1. Then this friction acting, what happen? It will try to drive the vehicle forward. So then what happen? The friction on the rear wheel will act like this. Then it will, the wheels will have in fact same angular acceleration, like just now what we discussed, and the total acceleration is this one. So in this case, what you can write, F1 minus F2, total mass m naught, you write it. I'll make a difference into A. So then what is the equation? There's a net force acting on system. Then on the front wheel, tau E minus F1 into R should be equal to I naught alpha. F2 into R is equal to I naught alpha. Individual cylinders, and for pure rolling, A should be equal to R alpha. What is R? R is the radius of this one. If the front driven engine, if the vehicle is front driven, front wheel driven, think like this. If the rear wheel driven, I just shown. So very good conceptual question they'll ask you. No need, sir, like an engine, sir, how engine will drive. It's immaterial. You join IITs. When you become mechanical, you start thinking. At this level, at least you must have this much of basic idea. It's a part of syllabus. Everyone must learn things of this kind. Front driven vehicle front driven engine and rear wheel driven engine. Can be asked as a conceptual questions. So how the roading frictions will act? This is a necessity. If you go for smooth road, what will happen? Your vehicle, will it move forward? No, not possible. Try to understand. The road is smooth. Though this, if you switch on engine, the vehicle will not move. Tell me like what is essential now? This should be rough enough, no? The road should be rough enough. If the road is very smooth, what will happen? The friction will not be sufficient, slipping occurs, and the vehicle may not move, or slipping will occur. So therefore, pure rolling conditions must be there. For that, what happen? The roads, the tires, everything are designed scientifically. Getting the idea? So that's why I think some of you tires, what happen after some use, what will happen? The layer on that, what happen, will diminish, no? Will decrease. So then what happen? Will go for refurbishing of tires. But the refurbishing, what happen, will not be done scientifically. So when you put that refurbishing tires to the vehicle, no, pure rolling will not be there. Slipping will be there. What it will do? It will consume your fuel. The mileage will come down. So therefore, refurbished tires should not be used. The factory made tires only, because they are so designed that friction will be sufficient for pure rolling. Everything matters. You can't take any diversions. I think I'll end up class. Okay, fine. Thank you, all of you. Tomorrow we'll see problems. Tomorrow, if you permit me some around